Hey guys, it's Mr. Hing here. I hope you're so well and welcome back to the channel. Today what we're doing is part 2 of area and perimeter. Guys, this is the video where I'm actually going to be showing you how to calculate area and perimeter for the different shapes. So please stick around till the end because there's actually going to be really good examples of how to do area or calculate area and perimeter. So why don't we jump right in? So firstly, guys, the things that we need to understand or know, you need to study these. I know it's terrible, but you need to know and study these is that we need to know the formulas of every shape, right? But the more you do it, the more that it'll come naturally to you. So firstly, I'm going to explain. When I say A, when you see the letter A, I'm referring to area. When you see the letter P, I'm referring to perimeter. So for a rectangle has a length, obviously, or two lengths and two widths, or breadths, if you want to call it. So what's going to happen, guys, is that the formula of area is equal to the length times the width, okay? So let's say, for instance, we get an answer of 40 centimeters. Please remember that when we have our answer for area, our unit is always squared. Okay, and then for perimeter of a rectangle, guys, you're going to take the length plus the width. You're first going to do that little sum in the bracket, and then you'll times it by 2. Why? Because this side over here is also the same measurement as this length over here, because a rectangle has two lengths and two widths, okay, or breadths if you want to call it like that. Okay, let's move on to a square swiftly along. All right, so a square, we know it has four lengths, right? So let's look at the area formula. It's going to be the length times the length, or you can also say length squared. Can you see that? Length times length is also the same as length squared. So for an example, if our length was 6, we would just say 6 times 6, and that will equal 36 centimeters. And don't forget to put your square because it's the measurement of the area. Okay, and then perimeter is nice and simple. It's just the length times by 4. Why? Because it has 4 lengths. 1, 2, 3, 4. 4 lengths. So you take one of them and you times by 4 to get the perimeter of the entire square. Okay, for parallelogram, guys, it's simple. You just take the base, right? The base over here of the parallelogram, and you simply times it by the perpendicular height. Okay, for perimeter, you just add all the outer side lengths together. And now, guys, let's take a few moments just to ponder on triangles. So, guys, regarding triangles, there is something that's very important. All right. Firstly, the formula for area is definitely half base times perpendicular height. Okay, the height must be 90 degrees. However, please, when you are using base and height, they need to have, that's why I drew this little yellow arrow here. It needs to be the correct base and height being used together. Now, what do I mean by that? Well, what I mean is that if we are going to choose our base, we need to define what our height is, perpendicular height is, correctly. Now, please pay attention. The height that we are allowed to use, there are 3 conditions for the height to be a correct height with the corresponding base. Firstly, the height always needs to be the perpendicular height. Secondly, the height needs to be drawn from the opposite vertex, or the vertex opposite the base that you are using. So when you choose a base of a triangle, guys, the perpendicular height needs to be drawn from the vertex or the corner of the triangle opposite the base. So let me just get a little color here. So let's get green. So say, for instance, I do choose this side as my base, right? Then what is the only vertex or corner opposite this base? It has to be this corner over here. So the height must be drawn from there all the way down up until the base. Okay, I'm going to give another condition just now for this triangle, but in this condition, it is drawn from the vertex opposite the base down towards the base. Sorry about that. That was a little phone call, and those were my pet dogs. Sorry about that, guys. Just a little interlude. Yeah, I'm still house sitting, so those were the dogs. Okay, but where were we? Okay, so guys, it needs to be drawn from the vertex opposite the base that we chose, all the way down to the base. Okay, and there's another condition that we're going to use here. Let me show you. So for instance, if we use the base of this triangle, what is the rule? It needs to be drawn from the vertex opposite the base, which it is here, this height. And when it goes down, I said it needs to go down towards the base, right? It needs to touch the base. Or it could touch an extension of the base. So this dotted line, green line over here is, can you see it's an extension of this base over here? So those are the three properties of our height being a correct height. Okay, I'm going to go through that again. So please listen up. All right. So the three conditions are for the height to be a height that is qualified to use in the formula. It needs to be 90 degrees towards the base. It needs to be drawn from the vertex or the corner opposite the base that you have chosen, and it needs to be drawn down towards the base or an extension of the base. Okay, so those are the three conditions for choosing a correct height with your base. Okay, and then the perimeter is simply adding all outer side lengths together again. Okay, and then this one I just asked, where will our base and our height be? So in this case over here, guys, I chose this to be my base. So if I do that, because remember, you can choose any side to be your base, but the height must be the correct height. So there is actually only one base that you can choose over here because the height is perpendicular over here. So I chose this to be my base. My height needs to be drawn from the vertex opposite the base, which it is, all the way down. It meets 90 degrees and it is at an extension of the base. So therefore, I can use this formula correctly over here. The base will be this base. The height will be this height over here. So let's go actually and implement this over here, guys. So if the question is calculate the area of triangle A, B, and C, what we're going to do is we're going to definitely say half base times the height. Okay, that's correct. And then what we are going to do is we're going to choose our base. Let's choose 5,6 centimeters. Okay, remember, sorry, I forgot this part. It's half times the base, and then times the perpendicular height needs to be the vertex, the corner opposite the base. So there is something here, and it's being drawn down towards an extension of this base, and it meets at 90 degrees. So therefore, this height of 3 does qualify to be a correct height that we can use. So put that in your calculator, and you should get 8,4 centimeters squared. Please remember that squared, guys. Okay, let's head over to circles and trapeziums. Okay, guys, so for a circle, firstly, let's get our definitions correct. I said in the previous video, which you can go and watch, it's part 1 of area and perimeter. The circumference of a circle is the distance around the entire circle. So it's basically from the starting point of the black, you go all the way around and you come all the way back to that spot. That will be your circumference that you need to usually calculate and work out. Then what is a diameter? A diameter is a point on the circumference, right? A point on the circumference. So we're starting over here, for instance. It goes down towards the center and through the center or middle of the circle towards the other side of the circumference. That is a diameter. What can we see a relationship between diameter and radius? Radius is also a point from the circumference towards the center of the circle. However, it doesn't extend towards the other side of the circumference. So we can conclude, we can say that, okay, then we know our radius is actually half the measurement of a diameter. So that's actually what I said over here for us. The radius over here is equal to the diameter divided by 2. It's halved, okay? And then for area of a circle, guys, it is pi times the radius squared. Please remember that, okay? Pi times the radius squared. And then for the circumference, also, you can kind of think of it as a perimeter. The circumference is equal to 2 times pi times the radius, okay? Or it can be pi times the diameter. Okay, so you guys must use this formula in order to work out area and circumference of a circle, which we will do just now. Okay, hang in there. We're going to get to the examples now of these types of questions for calculating area and perimeter. And then lastly, guys, what I'm touching on is trapezium. So for instance, guys, when we have a trapezium, what do we know about trapeziums? We know that there are one pair of parallel lines. Now, the area of a trapezium, guys, we will use the length of both the one pair of parallel sides. So we'll use this length and we'll use this length. And then the other thing that is very important is the perpendicular height. Those are the three things that are included in the formula for area. Okay, so let's have a look. We say in brackets half times this length over here, which is b, times the perpendicular height, a closed bracket, plus half times the length, which is a over here, times the perpendicular height. Okay, so those are three things. When you think of area of trapezium, you need three things. The length of the two pairs of, or the length of the two sides that are parallel to each other, and the length of the perpendicular height. So guys, let's get straight into applying what we have learned. Okay. Oh, and then obviously, guys, for perimeter for trapezium, you just add all the outer side lengths together, which is quite common to most shapes. Okay, let's have a look. Yeah, so that's perimeter. Okay, let's have a look at question number 1. It says the area of a rectangle is 200 centimeters squared. Okay, its length is 50 centimeters. What is its width? So guys, whenever we get a question like this, please try and put your formulas first. So let's just zoom out here so I can show you what the formula is. So we know formula for a rectangle is length times width for area of a rectangle. Okay, so let's just zoom in there and let's do the calculation together. So we are going to say we know that its area of a rectangle is length times the width. Okay, then what we can do is we know that our area is 200. So let's replace the area or the A with 200, right? Everyone makes that makes sense with everyone, eh? For everyone. Okay, so it's 200 is equal to the length is going to be 50 and then times by w. We do not know what the width is. So remember, guys, in algebra, if we have 50 times x, for instance, it's the same as writing 50x. And remember, guys, in algebra, if we want to get rid of this 50 in front of the x, we need to divide by 50. So that's what we're going to do over here. We're going to divide by 50, and whatever you do to the one side, you do to the other side. So 200 divided by 50 gives me 40. So it will be 40 centimeters is equal to my width. Okay, and that is what it asked. It asked for what is its width, and this is our answer, guys. Okay, well done. So let's carry on and go to question number 2. Okay, now, if ABCD is a square, calculate its area and perimeter. Now, guys, when we get a question like this, it's really good to draw a rough sketch of a square, okay? And we know that in a square, squares only have lengths, okay? All of the sides have the exact same length. So what do we know about the formulas of a square? So firstly, let's calculate the area. So the area is, we said it was length times length, or it can be length squared. So you simply just put that in your calculator. So area is going to equal 10 times 10, which equals 100 centimeters. Centimeters what? Squared, because it's area. Okay, let's move on to perimeter. So perimeter is equal to, you can say the length times by 4. Why? Because there are 4 of the same lengths. Okay, so it's just going to be 10, which is the length, times by 4, and that is going to equal 40 centimeters. Okay, and that is the perimeter, and this was your area. Okay, nice, guys. Let's keep going. Okay, this question is, if a square has an area of 200 meters squared, what is its length? Ah, this is interesting. So remember, squares only have lengths. So let's put our formula of area down. So area equals length times length, or it can be length squared. Remember that. So now what's going to happen, guys, is that we can actually again substitute what our area value is, which was 200. So 200 is going to equal, let's bring this over here, it's going to equal our length squared, and we don't know what our length is. So guys, can you see that we have our number over here and we have our unknown over here? So guys, what do we do when we need to get rid of a square? We need to end up square rooting this. Okay, and if we square root this to get rid of the squared, we're going to square root the other side. So then what's going to happen is you put that into your calculator, and it will be the square root of 200, right, equals our length. So our length will equal, is it 14,14? Let me just check in the calculator, centimeters, and I'm just running off to 2 decimal places. So that is our answer, guys. Okay. All right, yo, that was a pretty straight line. Freehand. Okay, so that is our answer, guys, for the length. All right, it's as simple as that. And now, guys, what I wanted to do was a circle question. So let's have a look over here. All right. So the diameter was supposed to be 18 millimeters. Okay, sorry, I don't know why that didn't come up. So let's read the question. It says, calculate the circumference and area of each circle in the diagram below. Use 3,142 as, and then there was supposed to be pi here. Okay, so guys, what is interesting is that what can we pick up? We have a big circle and we have a small circle. Am I right? So if we had to calculate the area of the big circle, can you see that it's covered up by the area of the small circle? So we'll need to do some subtraction for that. So why don't we go ahead and calculate the area of the small circle first. Okay, so area of a small circle. Okay, let's do that. So what did we say area is equal to? Well, let me quickly help you guys. Area is pi r squared, and they said for pi we're going to use this number 3,142. So let's go ahead and write that in. So area equals pi r squared. Now, do we have the radius, guys, for the small circle? Yes, we do. It's going to be 3 millimeters. Okay, 3 millimeters is the radius of the small circle. Can you see that green line there? Radius is, what's the definition? It's a point from the circumference to the center of the circle. That's the radius. So it said that we need to use 3,142 as our pi. So it's going to be 3,142 times by the radius, which is 3, and please square that. So that is going to equal, I'm just going to put in the calculator here. That's going to equal 28, comma, to, let's round it off to 8. Okay, we rounded it off here. So that is the area. Remember, it's millimeters squared. That is the area of the small circle. Okay, guys, now let's calculate the area of the big circle. Okay. But remember, guys, if we are going to calculate the area of the bigger circle, okay, well, I guess we can interpret it in two ways. Let's have a little conversation about that. Either we can calculate the area of the big circle looking, let me just make it a bit bigger here. Like this whole thing over here is the big circle. Are you with me? Or guys, we could think, okay, the question is trying to catch us out a bit, and the area of the big circle is just this over here. So what I'm going to do for purposes of like the simplicity of the question, I'm just going to make the area of the big circle the entire thing, okay, for this question. But please, if they for instance, if a typical question may be calculate the area of the shaded area, right? Calculate the area of the shaded zone or shaded region, then you would need to take the area of the big circle minus the area of the small circle, and then you would get the shaded area. Are you with me? So for the simplicity of this question, we are going to calculate the area of the entire thing, okay, the entire circle without any subtraction of the area of the small circle. Okay, just wanted to clarify that with you guys. Now let's go ahead and calculate the area of the big circle. Okay, so it's going to be area is equal to pi r squared again, guys. So pi is what? We're going to use 3,142 times it by the radius. Now, guys, what is the radius? The radius is equal to the diameter squared, because in the big circle, we do not have just the radius. We have the diameter, which is 18 millimeters. So what did I say? The radius is half the diameter. So if we do that, that's going to be the diameter is 18 divided by 2, and therefore our radius is going to be 9 millimeters. So let's do that, times 9, and it's squared. So put that in your calculator, and you are going to get the answer of 254,50. What is it? It's millimeters. Is it squared? Yeah, it is squared, because we're dealing with area. We're dealing with area, guys. So whenever we're dealing with area, we put the units being squared. And then finally, guys, we can go and calculate our circumference. Let's do it over here. So I'm just going to put C for the small circle. So let's see. So it's going to be C is equal to 2 times pi times r. So it's going to be 2 times 3,142 times by the radius, which is 3. So that's going to equal 18,85. Guys, all of these answers are not rounded off. I'm just rounding it off for you for the sake of just showing you how to actually get your answers. And the answer is millimeters. Okay. And then lastly, the circumference for the big circle is going to be C is equal to 2 pi r. So it's going to be 2 times 3,142 times by the radius. And guys, what did we say the radius for the big circle was? The radius was 9. Okay, so let's put that in there. 2 times 3,142 times 9, and put that in your calculator, and you should get times 2 times 9 times 3,14, and we should get 56,5. So it should be 556. That's the actual answer. And then please, according to how the question asks you, just round off correctly, but I'm rounding off to 2 decimal places. Okay, so guys, that is it. That is our answer. That is how we calculate area of circles and circumferences of circles. I hope it's helpful. I just wanted to take a simple question to explain the concept and how to apply everything. And yeah, guys, I hope that's very helpful. If it is, please like, share, and subscribe. It is helpful so that this content can get distributed nicely. And yeah, I always like to say, if you have any comments, please do put them in this comment section below, or any questions that you have. And yeah, I'll try and get to it as soon as possible. Another thing, guys, is that I actually realized there's a community little section on YouTube. So if you want to paste or post a question, like an actual question from a paper, please do, and then I'll make sure to answer it as soon as I can. But from me to you guys, it's Mr. Hing. I hope this is helpful. Thanks. See you in the next one.